Good morning. I won't necessarily be doing this for all of the lessons, but I do know that point slope is a difficult concept for a lot of people to grasp when they first see it. I know for many of you, you've gotten accustomed to a different point kind of a line. So I thought I'd just kind of give you a little bit of a presentation. It'll be shorter than most of the ones that you see, and it won't be super thorough, but I thought maybe just seeing a slightly different representation might help, because I noticed some of you are really struggling as you go through there and you're missing a number of problems because you're just missing something. So maybe seeing a fresh perspective might help. So I'm going to go ahead and I've set up a series of problems and we're just going to take a look at it. So this is actually the form of a line that most of you are probably very, very comfortable with. It tells you, of course, this is in slope-intercept form. It's going to tell you to start at the number 5. You're going to put your dot right there at the number 5 on the y-intercept. And then that tells us to drop 3 and run 4. And I think most of you, 1, 2, 3, 1, 2, 3, 4, are probably fairly comfortable with that form of a line. And it's pretty easy to do. And as you go through that, we're going to try to use this a little bit. And when we talk about the slope, which is this portion of the thing, which a lot of times you hear in this version, which is rise over run. The rise, it tells you how much your y value has changed, which is what this is what is saying right here for your slope m. And your run would be how much your x is changing, x2 minus x1. Now, the reason I bring that up is if you were to consider this like a fraction and you cross multiplied, the number 1 times this is y2 minus y1. And if you cross multiply this way, you'd have m times x2 minus x1. Now, that helped me when I was a student myself because I sometimes messed up this new form of a line. Well, what you're looking at right here is basically this new idea called point slope form. The only thing is instead of calling this y2, we just call it y, because y2 would be like a very specific point, like these 2 points right here. We are just going to have the x and the y value can move around a little bit. They're going to be called variables. Okay, and so that's kind of what happens. Now, with that being stated, we can actually look at the problem like this. So let's find the equation that has a slope of 3. So this is saying that the m value is 3, and it goes through the coordinate -1, 2. So what I'm telling you is that x1 is -1, and that y1 is the number 2. Now, this kind of bothers people because I think they're used to this idea right here, but if we were to come to the coordinate -1, 2 and put a dot right there, I think very quickly we could see that if the slope is 3, now keep in mind as a fraction, that's 3 over 1, I could go up 1, 2, 3 and run 1, and that would actually, even though I didn't start with my y-intercept, I can come up with a nice line just by knowing a point and a slope. So notice the point with the slope gave me a nice line because it provided me with 2 points, and I could connect the dots. But if we look at this form right here, what we're going to do is we're going to say y take away that y1 value. And that y1 value right here was the number 2. So we're going to do y minus 2 is equal to m, but the m was 3. Keep in mind the slope m in the equation goes here. And then last but not least, we're going to go ahead and do x minus the x value. But that x value, unfortunately in this case was negative. So that means I have y minus 2 equals 3 and x plus 1, because you'll notice that double negative that is right there. And I think you've seen that too. Now, a lot of people don't like this form of a line. They prefer a line that looks like the one that we had up here. This looks a little awkward, but you can actually see the coordinate -1 and positive 2 with a slope of 3 right from it. But if we wanted to, we could use the distributive property, take 3 times x and 3 times 1. And the only thing I would have left to do to make it look like y equals mx plus b is get rid of this little 2 that is sitting right here. And so I ended up with an equation of 3x plus 5. Now that shouldn't really surprise you that the slope was 3 because we were told that it was 3, but check out the y-intercept is 5, and if you look right here, when I did my rise and my run, I landed perfectly at the number 5. So I thought we could maybe look at a couple of those. So the second one that I have is, let's imagine now we go back through the process and it says, let's find that equation that goes with this slope and that point. So we're going to do y, take away that y value. We're going to have x, take away that x value. And remember, the equation was y, take away y, m, and then x, take away x. So the only thing I don't have yet is the m value, which I'm going to put right here. So in terms of graphing that, and I know in the lesson it didn't ask you to graph, but I think that's actually very, very important. If you go to -6, 4, some random point way out here off to the side, it tells me to have a slope of -2/3. That drops 1, 2, 1, 2, 3. There we go. And I have a nice, and you'll notice that I personally like to use a straight edge because we can see something. Now, what I notice is it looks to me like this line hit perfectly through the origin. In other words, a y-intercept of 0, but we're going to see. So I'm going to go ahead and do what I did up in this problem right here and distribute. 2/3 times x is 2/3 x. Now, this is trickier, and that's why I put it on there. When you multiply a fraction, we take 2 times 6, which is 12, negative. So we got -12, and I'm going to divide that by 3. -12 over 3 is -4. And so, of course, to get it the rest of the way, the only thing I need to do is get rid of that 4. And we are done. And notice the 4's cancel, and we got a y-intercept of 0, like the picture kind of indicated. Now, just to make sure that you understand, in many classes, it's okay to leave your line in this form. That's called point-slope form. But sometimes we like to put it in this form right here, which is called slope-intercept. So that's kind of my first introduction. Now, in your videos that you do in Acellus, they sometimes will go a little bit further and they will say, well, you know what, instead of looking at the problems that we have, let's go ahead and give you 2 points. So one thing you can do to find the slope is look back at that formula. Now, unfortunately, I like it better when they give me the slope, but in this case, they didn't. So this says, let's take the second y value minus the first y value. So let's see the second y value right here minus the first y value, which is 5, over the second x value, which is 1, minus the first x value, which is 4. So I see -1 take away 5 is -6, and 1 take away 4 is -3, for a total slope of 2. Now, that's pretty good. That wasn't so bad. But let me double check something because, you know, I make mistakes too. So here's 4, 5, and here is 1, -1. And I could look at this right here. Here's my line. It looks like I'm probably going to have a y-intercept of -3 later on, but let's just see. When I look at this, one thing you can do is you can make a little slope triangle. And if we go like this and like this as a picture, it sometimes helps. I went up 1, 2, 3, 4, 5, 6. I went up 6. I went 1, 2, 3 over 3. So if it was rise over run, that was 6 over 3, which is 2. And that kind of matches. So I personally really like making a picture instead of using the equation, but if I don't have graph paper, it's all right. So let's go back to that thing. We're going to go y minus the y value and x minus the x value. And just to be clear, you can actually do either one of these points. I know it says 1, But you could actually use either one, but we're going to do y minus the y value, 5. We're going to take x minus the x value, 4, and then remember the slope that we've been finding goes there. And so again, this is a good form of a line. It's perfectly reasonable. My calculus students are asked to leave it in that form. But often people don't like it, so we can do 2 more steps, which is to distribute 2 times x and 2 times 4, and then move the 5 across by adding it. And we have our nice little form that is 2x minus 3, and what do you know? It hit at -3. So last one was here. Again, we'll go ahead and take a look and find that slope. Let's see, y2, -1, minus y1, which was 5, over, let's see, I called this one y2. So over x2 minus x1. Now, I did this on purpose because I did want you to see one problem that was a little bit harder. This one didn't come out to be a nice perfect number. I got -3/4, which is actually pretty nice mathematically. And I did make it kind of nice, but so let's see, that was -4 comma 5 up here, and that was +4 minus 1 right here. And one of the reasons I personally like to graph them is it kind of confirms that this thing does go downhill, because sometimes I have a tendency to make negative sign errors if I go too fast. But let's go y, take away the y value, 5. We'll do x, take away the x value. Notice I took away a -4, that's why it's +4. And we're going to put the slope in front. Again, great form of a line, nothing wrong with it. We could leave it there, but often they want us to go a different way. Many teachers want to go to slope-intercept, so we're going to distribute. And just like you saw in that previous one, -3 times +4 is -12. So -12 divided by 4 is -3. And then, of course, the only thing we have left to do is add that 5 to both sides, and we end up with -3/4 x plus 2 as my slope-intercept form of a line, which you can see fits right here. Now, if you don't have graph paper, it turns out you can actually take a look at it in using some programs. So in Desmos, I just set myself up to that first problem that we had a few moments ago. We had -3/4 x plus 5. See, we can look at that right there. So notice the coordinate 0, 5. If we drop 3 and run 4, I believe when we dropped 3 and ran 4, we hit the coordinate 4, 2. And you can actually see right on there, and you can even label the points if you want to. So I'm going to go ahead and turn that stuff off, and let's look at question 2. In question 2, I had -1, 2, and I had a slope of 3. And so in point slope form, we had y minus 2 equals 3 times x minus -1, or x plus 1. So notice we have this thing right here. My coordinate -1, 2 is sitting right here. And one of the things that, I personally like to do is go ahead and write it both ways. So that was my point slope form. And then I'm going to write my slope intercept form, which I had y equals 3x plus 5. And you're going to notice that that black line, 3x plus 5, landed right on top of the other one. So it tells me I know I did that problem well. So I don't want to keep this one too long, so let's look at the very last problem that I did. I'm going to look at Q5 here, and that was the one that went through these 2 points. Again, it only took me a moment to put those in, and so when I did it in point slope form, my line better hit those 2 points, but my line was y minus 5 equals -3/4. And by the way, if you've never used Desmos, 3/4 is literally just 3/4 on the keyboard, because it understands fractions. And inside the parentheses, we had an x plus 4. And notice the line perfectly hit my points. And then of course, we simplified it, and hopefully when I type this 3 over 4x, oops, I put that in the wrong spot, 3 over 4x. If I put a +2, hopefully it's going to go right through that other line and it's going to hit the points and be right on top of that red line. And what do you know? It did. I don't know why it got all fuzzy that way, but it did. Anyway, that's my little quick take on graphing and point slope. And I hope that's helpful to you. I hope a couple of you actually watched that. And I just thought it'd be nice if you got to know me as your teacher, because I actually would like to be your instructor and not just somebody that manages the SLS format. So anyway, I'll see you soon. Bye-bye.